Alright, we've got room here for problem 5. Determine algebraically whether the given function is even or odd. F function is even or odd. So if it says determine algebraically, you have to show it on the scratch paper. And we're given f of x is equal to, let's say, 2x squared plus 3, or plus, let's say, instead of 2x to the squared, let's say 2x to the 4th plus 3x squared. And so what we would have to do here is we would have to substitute in negative x. And so it's like we're cutting the x, cutting the x, cutting out the x, put parentheses. And so this is f of, and actually I want to do this. Plus 3. And then we're going to substitute negative x in. Negative x, negative x, negative x. And so negative x to the 4th, that's just 2, that's like saying 2 times negative x times negative x times negative x times negative x. So you get 2, that comes out to be 2x to the 4th. Plus, and this would be the same 3x squared. And so, since it comes out to be the same, we would say that if we get negative x, f of negative x equals to x, this would be an even function. So in other words, we substitute negative x in, and you get the same thing you started with. That's an even function. Well, what would be considered an odd function? Well, if we had f of x equals to, let's say, x cubed plus x, and we substituted negative x in, so this would be negative x cubed plus, and then negative x, substitute those in, and we get negative x cubed minus x. So here we put negative x in, and we get a negative. All the signs change. This would be an odd function. And if you don't either get all the signs change or all the signs stay the same, then you would have neither. Okay. That is problem 5. Alright, so let's look at problem 6. And let's say we have this graph here. And let's say it comes up and down, and then it ends here and ends here. And we have these points, and let's say this is negative 1, negative 3, and this is positive 1, 2, and let's say this is 2, negative 1, and let's say this is 3, 4. Okay, and we want to know, find the absolute maximum and absolute minimum. Find absolute maximum and minimum, absolute minimum. Okay. So the way the question is going to be worded is, the absolute maximum, and I won't write whole maximum out, of y equals to f of x is. And basically the max or min are going to be the y values, right? Now normally the way we would answer it in class is the absolute maximum is, in this case, 3 at x equals to 4, but they're not, the test won't ask for this part. It'll only ask for the maximum or min. So try to figure out the absolute minimum. The minimum of y equals to f of x. So this y equals f of x, that should be a clue for you that you're just looking for the y values, which is a -3. Alright, and that would be at x equals -1, but they're not going to ask for that. Now how about the local maximum? What's that? Local maximum, that's where the curve, it comes up, reaches a peak, and then comes back down. So local maximum is different than absolute maximum. So local maximum there is, you should have said 2 at x equals 1. Alright, and then the local minimum, you should have said -1. Okay, so that's pretty straightforward. Alright, and that was question 6. Alright, question 7, determine algebraically whether the given function is. Alright, we did that, so you'll see another one like that. Question 7, solve the system of equations. Whoops, didn't want to do that. Where am I? Here we go. Solve the system of equations. And let's say that we have here y plus 3 equals 0, and we've got 3x plus 2y equals to 5. Alright, well what you want to do here is you can say, alright, if I were to subtract 3 from both sides, I could get y equals to -3, and then substitute that in. And so that would be -3 in for y, so that'd be 3x plus 2 times -3, and that'd be 3x minus 6 equals to 5. So we would solve for x, and so we would add 6, and we get 3x equals to 11. Divide by 3, and we get x equals to 11 over 3. Well, we have y already. That was 3, -3 rather, and so this would be 11 over 3, -3, and that's your answer. Okay, and that's all there is to that one. Okay, now